Okay, grade 10s, we've spent 2 days completing the square, which I told you was the most brutal part. And our whole goal here is to go between the different forms of a quadratic equation so we can find all the stuff, like the x-intercepts and the vertex and so on. So we've done the hardest one, which is going from standard to vertex form to find the vertex. So here's the three forms. Y equals a, x minus p squared plus q, which is the one that we started with, which is called vertex form. And we can find the vertex, the axis of symmetry, the maximum or minimum value, and we can graph it very easily. This form, not so nice for finding x-intercepts. Possible, but not nice. We can find the y-intercept by putting a 0 in for x. So we know a lot about this form. The last 2 days, we've been looking at comparing that to standard form. So standard form has no brackets anywhere in sight. And we were noticing that the thing that it gives us the most easily is the y-intercept, which is your c value. It has the same a, which tells you whether it opens up or down, skinny or wide. But it doesn't tell you the vertex, the x-intercepts, and so on. So what we have been doing is completing the square. So our goal is to be able to go back and forth between all three forms to find the stuff. So the one that we haven't spent time with yet is factored form. Factored form can have an a as well, and it would have two sets of brackets in factored form, like when we did all that glorious algebra. X minus, let's call this b, and this c. So we have it in fully factored form like that, and today's goal is to look at going between standard form and factored form and seeing what that tells us. We have done all these skills before, we just need to recall. So I'll do a few examples with you today. Here's the first one. I have this equation in vertex form. I want to write it in standard form. That means no brackets anywhere in sight. So I want to expand or multiply, distributive law, FOIL. Those are the things that I'm thinking about. So if I have x minus 3 squared in brackets, a really good strategy is to write that x minus 3 out twice so that you remember a square means two of them. You're going to have a FOIL. My choice is to leave the 2 for later and FOIL the brackets first and then do distributive law. That doesn't matter as long as you're careful. So if I FOIL that, I'll have x squared outside, negative 3x, inside, negative 3x, and lasts would be positive 9. My choice second would be to tidy up that bracket first. So I'm going to put the two x's together, the two piles, and I get negative 6x plus 9. Some of you can do that in one step, and that's fine. Again, as long as you're careful. My choice then would be to use distributive law. So 2x squared, subtract 12x, plus 18, subtract 7. And I'm almost there. I just need to put that 18 and negative 7 together, and I have final answer, 2x squared, subtract 12x, plus 11. So what do I know? I know without doing any calculations that the vertex is 3 to the right down 7, which means I know my axis and my maximum or minimum. But I also know the y-intercept now. It is 0, 11, and that comes from my second form. This one, y equals 2x minus 5 times x plus 7. I have it in factored form, and I have been asked to put it in standard form. If I am going to put it in standard form, I am going to FOIL this. 2x squared outside would be 14x. Inside is negative 5x. And lasts would be negative 35. I can combine like terms, so my final answer would be 2x squared plus 11x subtract 35. What I know now is that the y-intercept is negative 35. From my original form in factored form, I know the x-intercepts, and we're going to spend a little bit more time looking at that in a minute. So I think I'll leave this one for now. Here we are. We have an equation in factored form. I know my a value is negative 3. That means it's upside down and skinny. In factored form, I know my x-intercepts. Again, we'll talk about that in a minute. And I've been asked to write it in standard form so I can find my y-intercept. Standard form has no brackets anywhere in sight. My choice would be to leave the negative 3 till later and do the FOIL first. X plus 4 times x minus 6 first would be x squared. Outside, negative 6x. Inside, positive 4x. And 4 times negative 6 is negative 24. So you can tidy up that bracket first or distributive law and tidy up later. I'm going to tidy up first. Negative 3 times, if I combine like terms, I have negative 2x. Subtract 24. Distributive law for final answer would be negative 3x squared plus 6x plus 72. So I know that my y-intercept is 72. Okay, last set of examples would be, I am going from standard form, so no brackets, to factored form. And this is where it can get really helpful. If I have y equals x squared subtract 81 and I want it in factored form, I'm going to look at my handy dandy factoring sheet and I'm going to do the walkthrough. Number 1, is there a greatest common factor that's more interesting than 1? Nope. Number 2, is it a simple trinomial? No, it doesn't have 3 terms, it only has 2. So chances are pretty good it's a difference of squares. And that difference is the giveaway. So this is a difference of squares, which is so awesome because a difference of squares is so slick to factor. You have 2 identical brackets where the firsts give you the x squared term and the 2 numbers give you the 81. They have to both be identical. One bracket has a positive, one has a negative, and that's fully factored. We're going to come back to that. So if you can leave a little bit of space, that would be helpful. Let's look at the second one. Y equals x squared plus 9x plus 20. I want to put that in factored form. I look at it and say, is there a greatest common factor more interesting than 1? Nope. Is it a simple trinomial? Well, it's a trinomial because there's 3 terms. The simple part comes from the fact that there's an invisible 1 there. It's not a different number that makes it a little more tricky, so we are able to factor it by putting up 2 sets of brackets, and we're thinking reverse FOIL. So I have x at the beginning of both brackets. I need 2 numbers such that the 2 numbers multiply to 20, the 2 numbers add to 9 from outside inside in FOIL. My 2 numbers, I brainstormed 20. 1 times 20, 2 times 10, 4 times 5. 4 and 5 would also add to 9. Everything's positive, x plus 4, x plus 5. Please leave a little bit of space for that one as well. We're going to revisit it and talk about what we have found. 2 more. Y equals 2x squared subtract 5x subtract 3. So some of you are already going, oh no, you know what's coming. I go through the factoring chart. Is there a greatest common factor more interesting than 1? No, there's not. Is it a simple trinomial? No, it is a trinomial, but it has that ugly 2. So I have to deal with this by decomposing it. It's a trinomial in the form ax squared plus bx plus c. So to factor this thing, I have to decompose that middle term into 2 parts. So I'm going to be rewriting this with that 5x looking a little bit different. I need to break it into 2 parts that they add to negative 5 because I can't change the question. But the same 2 terms would have to multiply to both of these put together, negative 6. So if I want to add to -5 and multiply to -6, I'm thinking about 6. 2 times 3 is 6, and 6 times 1 is 6. And I need to have a positive and a negative. So if I had a positive and a negative, the 2 and 3 won't work. But the 6 and the 1 will. And I chose the larger number to be negative, so that when I add them, I get a negative. So there's my two numbers. That means I can rewrite this 5x as positive 1x, subtract 6x. I haven't changed the question, I've just made it look different so that I can factor by grouping. It doesn't matter whether you put the 1x first or you put it second, it would all work out. So I'm factoring by grouping, 2 at a time. 2x squared plus 1x, my greatest common factor is x. I am factoring out, x times what gives me my first term, 2x. X times 1 gives me my second term, pause. I know what I'm expecting in my bracket for the second two terms. I'm expecting my bracket to be identical. So when I see two things are negatives, I'm going to take out a negative greatest common factor of 3 and just check that -3 times 2x is -6x, check. -3 times 1 is -3, check. I expected my brackets to be identical. My final answer would be, take out the common bracket, 2x plus 1, put the leftovers in the other bracket. If we did FOIL on that, we'd get what we started with. That is fully factored. Last one before we talk about what we found. Y equals -3x squared, -6x plus 72. So my check sheet would be, let's look for a greatest common factor first because it can make life much easier. I notice that there's a 3 in every term. And because I really like that x squared to be positive, I'm going to take -3 as my greatest common factor. -3 times what? -3 times x squared gives me my first term. My second term is going to be positive because I'm going to have negative times something to get a negative. I need 2 and I need an x. My last term is going to be negative because I want a negative times a negative to give me a positive. And 72 divided by 3 is 24. So I've taken out the greatest common factor. That tells me that it's upside down and skinny. But if I can write the rest of that expression in factored form, I have it fully factored. Simple trinomial, because there's an invisible 1 in front of that x squared. A simple trinomial means I can factor it with two sets of brackets with x and x at the beginning. To find the numbers that go in the brackets, my numbers need to multiply to -24 and need to add to 2. Okay, what multiplies to 24? 1 and 24, 2 and 12, 3 and 8, 6 and 4. The only two that could ever get you to a 2 by adding and subtracting is 6 and 4. I want my larger one to be positive so that it adds to +2. There's my two numbers. So in simple trinomials, those two numbers go right into the brackets, x plus 6, x minus 4. We have done this factoring so that we can find x-intercepts. You know for x-intercepts, your y value is 0. You can picture something that has x-intercepts here and here. You know your y value is 0 at that point. So we're going to use that fact to find x-intercepts, which is the hardest thing to find in quadratics. Let's start with the first one. To find the x-intercepts, I know that they're going to look like something with a 0. And I know from experience that sometimes I can have two x-intercepts. Not always, sometimes none, sometimes 1. But I'm thinking about the fact that y equals 0 for an x-intercept. So I'm going to take this equation and I'm going to say, all right, if it's equal to 0, what would x have to be? Well, I know something about 0. That 0 times anything is 0. So, and that's a big idea actually, so that if this guy is 0, or this guy is 0, then we're going to end up with a product of 0. That's where I find my two x-intercepts from. If the bracket x plus 9 equals 0, then we have an x-intercept of, let's subtract 9 from both sides, negative 9. That would give me a 0 in my first bracket, which means the whole thing would be 0. What if my second bracket were 0? If that bracket were 0, x would be 9. So my two x-intercepts would be 9 and negative 9. I know we've seen this before, and you knew that in brackets we would see the x-intercepts by considering the opposite sign. I should have written those backwards. All right. Let's look at the next one. Let's take a guess. What do we think the x-intercepts are for this one in green? Well, I'm suspicious of 4 and 5 would have something to do with my x-intercepts. But to find my x-intercepts, I am saying that if either bracket were 0, I would get a 0 for y. So I'm going to set the first bracket equal to 0, which tells me that one of my x-intercepts is negative 4. I've subtracted 4 from both sides. So I could write that as the point negative 4, 0. For my other x-intercept, what if the other bracket were 0, which would give me a 0 overall for y? My other x-intercept is negative 5. So we can see that the sign is opposite to what you're looking at in brackets for your x-intercepts. Okay, so this one's a little bit uglier. I have 2x plus 1 times x minus 3 is y. So if I want y to be 0 for my x-intercepts, I would set either 2x plus 1 equals 0 or x minus 3 equals 0 for my two possible x-intercepts. For the first one, I'm just solving like we did in grade 9. I'm subtracting 1 from both sides. And then I'm dividing both sides by 2. So one of my x-intercepts is negative 1/2. Some of you would notice that if you have a coefficient inside the brackets, you're going to have a fractional x-intercept, but still pretty. The second one, x minus 3 equals 0. If x is 3, y will be 0, which is my x-intercept. So I have 3, 0, and I have negative 1/2, 0 as my x-intercepts. Last, for my x-intercepts, I know they come from zeros in the brackets, so I have an x-intercept there, and I have an x-intercept there. We've seen the pattern that it's the opposite sign, so if x is negative 6, I will have a 0 in that bracket, and it will give me a 0 for y. If I have 4 in that bracket, I will have 0 overall, so I have found my two x-intercepts.